Hello and welcome back. So I have this question that said we should prove that sine theta all over 1 plus cos theta is equals to 1 minus cos theta divided by what? Sine theta. Okay, so let's recall from the first video our identities, right? So we are to make this become this. All right. So we can start with, if we call this one the left hand side, then we can call this the right hand side, right? So picking the left hand side of the equation, that's sine theta all over 1 plus cos theta, right? Then we can have that. If we remember conjugate of sorts, let's say I have a over 1 plus b, and I want to do the conjugate, then I can say times 1 minus b divided by 1 minus b. Do we recall that? Okay, if that is recalled, then let's apply it here. Let's apply it to the denominator. So sine theta over 1 plus cos theta can be multiplied by 1 minus cos theta divided by 1 minus cos theta. So since both of them are equal, you can cancel it to be 1. So 1 minus all this, it comes back to this. You've done something mathematical wise, but it's as if you've done nothing, right? Okay, so let's proceed. Now, if we multiply this by this, you're going to be having sine theta into 1 minus cos theta, all divided by, now look at this one, 1 plus cos theta times 1 minus cos theta. So it will be like this, 1 plus cos theta into 1 minus cos theta. Now look at this identity. Does it not look like a plus b into a minus b, which I explained in the first video that it will be a square minus b square? Do we remember? Okay, so if 1 is a and cos theta is b, then I'll be having sine theta into 1 minus cos theta to be all over, the whole of this now will become 1 square minus cos theta square from this identity, right? Okay, so this is going to give us sine theta into 1 minus cos theta, all divided by 1 square is 1, cos theta square is cos theta square, like this, right? Okay, now look at this one, the denominator here. It represents one of our identity, which was gotten from sine square theta plus cos square theta is equals to 1, where we say sine square theta can be equals to 1 minus cos square theta, correct? Okay, so if we substitute this value here with sine square theta, we'll be having sine theta into 1 minus cos theta all over sine square theta. Our aim is just to get this eliminated, right? So that it will look like this. All right, so if that's where we are, then let's note that the denominator can be represented in this way. This is same thing as saying sine theta all square. Is that also? Yep. Okay, so if that's correct, then we have sine theta into 1 minus cos theta, all divided by sin theta times sin theta, right? Sin theta square means sin theta times sin theta from a square, which is a times a, right? Okay, so this will cancel out this. So you are left with what? 1 minus cos theta, all divided by what? Sin theta. So you can see that it has been proven that sin theta divided by 1 plus cos theta is equals to 1 minus cos theta divided by sin theta. So we are proving it. So the right hand side is equals to the what? Left hand side. That's the final answer. So this brings us to the end of proving this identity. I'll see us in the next video. Bye for now.